This video kicks off the second half of our class CS61B. So in this half, we're going to concern ourselves with how do we write programs that make the most efficient possible use of our computer's time and memory. So we're going to write programs that hopefully run efficiently. That's in contrast to the first half of the class where we focused not on the computer's time, but on your time. We talked about, as a programmer, ways you can use debugging, testing, object-oriented programming, Java's type system, things like that. So we're moving on from that and now focusing on the efficiency of the program itself. In this part of the class, we're going to talk about really important topics that you may or may not have heard of, things like hash tables and binary search trees, graphs, and we'll be comparing and discussing trade-offs between different ways of solving the same problem. And along the way, we're going to have to start talking a lot more about math. This is going to require some more sophistication and more formalism, but it's not going to be super crazy. And for those of you who do want the super crazy treatment, I'll give you some links at the end of the 7 weeks if you want to go really deep into the math. I'll note some other changes. One is, well, it's been like 6 or 7 months since I've done one of these videos. There's now this new lovely wallpaper, and let me tell you that in the year 2017, it is not easy to find wallpaper paste in California. It took 4 or so trips to various hardware stores, and they had to dig it out of an old, trunk that they salvaged from a merchant shipping vessel that sunk. I'm guessing, I don't know. Anyway, all I know is it wasn't easy. But now you have this lovely stuff to look at next to me. I hope that makes the videos more fun. Although it wasn't just for you. We also had a baby. All right. So to give you a sense of what this part of the class is going to entail, let's consider the following problem. We have an array, and we want to know, does this array contain any duplicates? Well, there's one very silly algorithm where we have such an array, where we just look at every single pair, and we say, okay, is -3 and -1, is that a duplicate? How about -3 and 2? How about -3 and 4, and so forth? And this approach is not as good as an approach which takes advantage of the sorted nature of the array. A better approach would be to say, okay, let's look at each number and only its neighbor, because if it's sorted, a duplicate has to be next to it. And so in that way, we just look at these two, then these two, then these two, now we're done, and so forth. So hopefully you can get an intuitive sense that this second algorithm is better. But what we want to do in this part of the class is be more rigorous than that. We want to be formal. And so today's goal is going to be to derive some formal technique to compare this one to this one.